Hi guys, this is your digital anchor chart for MD2, which is a 5th grade standard. It says that you can make a line plot to display a data set of measurements in fractions of a unit in halves, quarters, and eighths. Use operations on fractions to solve problems presented in the line plot. So the first learning target is that you can create a line plot to display data in fractional units. And the second one is that you can solve problems relating to the data. So I have some data here. The scenario is that, our phones or our Fitbits or whatever track our steps and then usually correlate them to miles. So these are fractions of a mile walked in a day from 10 students or people, whatever you'd like to think of it as. So the first thing that we're going to have to do is take the data and display it on a line plot. Well, in order to do that, you've got to be able to create a line and plot the fractions on the line. So I have halves, quarters, and eighths here. So I need to split my line starting at 0 and ending at 1 because my highest data point is 1. And then I want to split it into eighths. So I'm going to split it first into halves, and then quarters, and then eighths. All right, so I'm going to first label my halves. This would be here.
Teachers, you may go ahead and bring up your call writers at this time and take your after-school children to after school. Thank you.
Miss Carmichael got to be in our video. Okay, so half is here, a quarter would be here. This would be 2 quarters, and 3 quarters is here. Then you can label your eighths. This is 1/8. This would be 2/8, 3/8, 4/8, 5/8, 6/8, and 7/8. All right, so now I have my number line created. I can plot the points for each of the data points on the line. So every time I have a fraction up here, I want to represent that on the line with an X. So the first one is at 5/8. I'm going to put an X over 5/8. And then I want to probably signify that I've used that one some kind of way. So I'm going to put a dot underneath it. The next one's 3/4, which is here. And same thing, just to help me keep track of what I've already used. We have 3/8. Then I have a half, another half, and a third half right there. 5/8 here, 3/4, 7/8, and 1. I should have the same number of X's on my line plot as I have data points to enter. So if I count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I should have 10 X's on my line plot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That way I know I've used them all and my line plot is correct and accurate. So then I also need to be able not only to create a line plot, but to answer questions about the line plot. So what is the greatest distance walked? So looking at the line plot, I'm looking for the greatest distance. This is in miles. The greatest distance is right there at the 1 because that's the highest value on my line plot. So I'm going to put 1 mile. All right, and what was the total distance walked? So to find the total distance walked, I need to add all of my data points together. Well, they're already grouped, so that can help me do that a little bit easier. So I have 3/8 one time. I have a half here 3 times. So that's 3 halves or 1 1/2. I have 5/8 twice, so that would be 10/8. I have 3/4 twice, so that's 6/4, or again, 6/4 is equal to 1 2/4, or 1 1/2. And 7/8. And finally 1. All right, so I've got a lot of numbers to add. I want to combine the things with like denominators first. So if I have, let me get another color. I have 3/8, 10/8, that's 13/8. Plus 7 more 8s would be 28. Okay, and I've used all my 8s. I can combine 1.5 with 1.5, and that's going to give me what? I hope in your mind you're saying 3. It's going to give you 3. And then I can combine it with the other one here. So 3 plus 1 is 4. Equals. All right. So 28, I need to convert that. 8 goes into 20 2 times with 4/8 left over, which is equal to 2.5. If I combine the 2.5 with that 4, I get 6.5 miles. So when you have questions like that, know it's going to be tedious. Find yourself a system to keep track of what you've used, what you've already, what you're finished with. Make sure that you combine like terms first so that you're not trying to add 10 numbers together at the same time. All right, then we have, what was the average distance walked? Okay, so to find the average distance walked, you've got to first define any average. You add together all of your numbers, and then you divide by the number of entries that you have. So we already have our total here. That's 6.5. And we need to divide it by the number of people that walked, which was 10 people, right? Well, in order to divide with a mixed number, I need to first probably convert that to an improper fraction to make that as simple as possible. 6 times 2 is 12 plus 1 makes 13 halves. And if I'm going to divide it by 10, remember that I can keep, switch, flip. I'm going to keep the first one. Switch my sign and flip the second one. So 10 is 10 over 1. So we're going to do 1/10. And then I'm going to multiply straight across. And I'm going to end up with 13/20. So that's my average distance walked. 13/20 of a mile. All right, basically, guys, you got to be able to take all the things, all the operations that we've learned how to do with fractions, and we've got to be able to apply them with a line plot. Really, the only difference between the 4th grade line plot standard and the 5th grade line plot standard is that now you're incorporating fractions. The standard specifically says halves, fourths, and eighths, so that's all you should expect to see on a standardized test. And then basically be able to add, subtract, multiply, and divide based on whatever question you're asked. All right, good luck with this. Bye.